The U.S. Centers for Disease Control and Prevention recently released a report demonstrating that the incidence of the zoonotic tick-borne disease, babesiosis, has increased in certain states. Today, we will discuss these data, the potential factors contributing to the spread of babesiosis, and research on the development of vaccines and new treatments for the disease. Welcome to Microbial Minutes, the American Society for Microbiology's update on what's hot in the microbial sciences. I'm Madeline Barron, Science Communication Specialist at ASM. And to begin, let's start with some background on babesiosis. This disease is caused by Babesia parasites that infect red blood cells. The parasites live in the saliva of hard-bodied ticks belonging to the Ixodes genus, with the primary vector in the U.S. being the black-legged tick, also known as the deer tick. There are multiple species of parasite that cause disease, with Babesia microti causing most tick-borne cases in the U.S. Besides being transmitted via tick bites, Babesia parasites can occasionally pass from person to person via blood transfusions and, more rarely, organ transplants or congenitally. Symptoms of babesiosis are rather nonspecific and can take weeks to show up, if they show up at all, as some people are asymptomatic. They can include fatigue, chills, fever, and, due to parasite-mediated destruction of red blood cells, hemolytic anemia. Severe disease, which may include organ failure, low blood pressure, and more, can occur in certain individuals, including those who are immunocompromised or of older age. In such cases, illness can last a few weeks to several months and may be fatal. Now, geographically, cases of babesiosis are largely concentrated in northeastern and northern Midwestern regions of the U.S. However, the disease does occur worldwide, and cases have been reported in Europe and Asia, and sporadically in other countries elsewhere in the world. The spread and number of babesiosis cases may be greater than current estimates suggest, given the lack of widespread tracking and reporting. And so this brings us to the new data from the CDC suggesting that, specifically in the U.S., the incidence of babesiosis has increased in recent years, and its endemicity has expanded. The report assessed babesiosis trends in 10 states, shown here, where the disease was reportable between 2011 and 2019. Over 16,400 cases of babesiosis reported in 37 states during this time, over 98% of them came from these 10 states. And of these 10, 3 states where babesiosis is now considered endemic, Maine, New Hampshire, and Vermont, were not listed as states with endemic disease in previous CDC surveillance summaries. This endemic status is, according to the CDC, based on the increasing numbers of cases, trends in rates, and presence of the B. microti parasite in ticks in these areas. These states also reported the largest change in disease incidence over the 8-year period, with Maine, for example, reporting 9 cases in 2011 and 138 in 2019, an over 1,400% rate increase. Overall, the incidence of babesiosis trended upward in all states except for Wisconsin and Minnesota, which had no significant change. The reason behind this is unclear. Moreover, the CDC stated that the report data likely don't capture all cases of babesiosis in reporting states, and incidence may be higher. Now is a good time for some context. Babesiosis is by no means the most common tick-borne disease. In the U.S. alone, there are over 23,000 confirmed cases of Lyme's disease, another tick-borne infection, in 2019, with another 11,000 plus probable cases. However, the CDC also noted that cases of tick-borne diseases in general increased by 25% between 2011 and 2019. Thus, the babesiosis data are indicative of this broader rise in infections by tick-associated pathogens. And while the CDC did not provide an explanation as to why the incidence and range of babesiosis and tick-borne diseases in general are increasing and expanding, scientists point to several possibilities. One reason is climate change. Ticks thrive in warm and wet conditions. As the climate changes, the range of ticks and their microbes may broaden. This highlights the larger trend in which warmer temperatures are promoting the expansion and migration of pathogenic microbes and infections. Now, to that end, milder winters associated with climate change may also allow ticks to stay active year-round, widening the time frame for infection. Growing deer populations may also play a role in the spread of babesiosis. While deer do not become infected by Babesia parasites, they do provide a breeding site for ticks and can help propagate the tick population to contribute to the spread of disease. The New York Times also reported that expansion of housing into areas where ticks are present may also facilitate transmission. It is likely babesiosis and tick-borne infections overall stem from a combination of these factors, among others. Of course, a key question is how to prevent babesiosis. Tried and true methods for avoiding tick bites, some of which are listed here, are your best bet. These methods, including avoiding tall grasses and wearing long sleeves and pants in areas where ticks are present, protect not just against babesiosis, but other tick-borne infections as well. The CDC also noted that the report's findings may have implications for the blood supply, given possible transmission via transfusion, stating the importance of ongoing evaluation of both tick-borne and transfusion transmission risks in states that border those with endemic transmission. And while there are currently no vaccines for babesiosis, there may be the potential for one in the future, particularly for high-risk individuals. For example, those who live and work in areas with higher chances of infection, are immunocompromised, and more. A recent review published in Trends in Parasitology outlined the prospects and feasibility for developing a vaccine for babesiosis, stating that the goal would be to either A, prevent the tick from transmitting parasites to a host, or B, prevent development of infection and/or clinical disease in the human host. To date, most vaccine efforts have focused on cattle and dogs, as livestock and other animals can also contract babesiosis, which can have important economic implications. However, there have been preclinical advancements towards developing whole parasite and subunit vaccines for humans. The authors of the review note that continued progress will depend on several things, including determining what type of vaccine would be most effective and how it should be used. It will also depend on gaining a better understanding of human immune responses to Babesia parasites. A majority of studies also take place in mice, which are the natural host for the parasite and may mount a different immune response. In the case of subunit vaccines, delineating which Babesia antigens are the best targets will also be critical. There have also been advancements towards developing new treatments for babesiosis. Current treatments consist of a combination of drugs, listed here, and are usually effective in most people. However, treatment failure can occur in some cases, and the emergence of drug-resistant parasites can complicate matters. This has prompted exploration into new drugs, or rather, repurposing existing compounds for treating babesiosis. For example, in a recent study, researchers explored the efficacy of a compound targeting Plasmodium parasites, which cause malaria and are related to Babesia parasites, against Babesia infection in mice. This study showed that the in vivo inhibitory effects of the compound on B. microti were comparable with the current drug treatment recommended by the CDC. When animals were infected with the highly pathogenic rodent species of Babesia, those treated with the compound survived, whereas the mice in the control group died within 10 days post-infection. Tafenoquine, another anti-malarial drug, was also affected, though it can induce hemolytic anemia in certain individuals, which limits its potential. Overall, the results of the study point to a potential new compound and strategy for treating babesiosis. Still, the scientists did find that the compound was less effective in mice with severe combined immunodeficiency, indicating it may not be applicable in all cases. And of course, this was conducted in mice and is far from being applied in human cases. So, what's the bottom line on babesiosis? Cases of the disease and tick-borne diseases in general have increased in the U.S. Babesiosis is now endemic in 3 states where it wasn't before. And while the factors driving this spread are unclear, climate change and a growing deer population may play a role. And, though preventing tick bites is key for avoiding infection, researchers are exploring potential vaccines and new anti-Babesia agents to prevent and treat this emerging disease. And that's all for today. Be sure to ring the bell to be notified whenever a new Microbial Minutes drops. I'm Madeline Barron. As always, I want to thank you for listening, thank Ray Ortega for production, and I'll talk to you soon.